Hey, Mr. Maestas coming to you today from my classroom and my whiteboard, and I'm going to go over sigma notation with you. So, gotta get going quickly so I go out to a football game today. So I'm going to get this done pretty quickly, and I think that hopefully you should get what you need out of what sigma notation is. So, sigma notation is just another way to write a series. And if you recall from the last video, a series is a sequence of numbers that's been added up. So what we're going to do is instead of writing out all of the terms added up together, we're going to write it in one simple, compact, nice, easy way to write it. And we're going to use the Greek symbol sigma, or the Greek letter. It's not really a symbol, it's a letter. So the Greek letter capital sigma. And so here's my sigma here. And everything's going to look like this. So what I have is I have a sigma, and underneath the sigma I have n equals. Now it doesn't have to be an n, it could be a k or an I or whatever variable you want, but it just gives us a place value. It tells us where we're going to go, where we're going to start, and then so here's where we're going to start. So that goes in the box there. We're going to have something 1, 2. Normally we start with 1, but it could start at 0. That's where we're going to start. And then we're going to plug that into our formula, which is inside the sigma. We're going to plug that into our formula for whatever variable this is. And then that's going to be our first term. Then we're going to increase that by 1. So whatever this n was, we're going to add 1 to that, and then we're going to plug that into our formula, and that'll be our next term. And then we're going to increase by 1, then we're going to plug that in our formula, that'll be our next term. Then we're going to increase that by 1, and we're going to plug that in our formula, and that'll be our next term. And we're going to keep going like that until this number up here tells us when to stop. So that's the n, and we're going to increase that by 1. So let me show you a couple of examples on how that works. So here's my first one. I have sigma, I have n equals 1. My formula inside is n squared, and this says to go from n equals 1 to 4. So I'm going to start at 1, and then I'm going to go to 2, and then 3, and then 4, and then I'm going to stop, okay? So this is how it looks. I'm going to write it out so you can see how it looks, and then you might not have to write it out the whole time here. But we're going to plug in 1 into here. So we're going to have 1 squared, okay? So that was n equals 1. Okay, now we're going to go again. N equals 2. So we're going to plug 2 in for n. And we're going to add them. Remember, sigma means to add. So add, so we're going to plug 2 in here. We're going to get 2 squared. That's n equals 2. Now we're going to do n equals 3. So plug in 3 into our formula. 3 squared. Got to keep going because the top number is 4, so I've got to keep going. So now we're doing n equals 4. Plug 4 in there. 4 squared. Now I stop. Okay, I did 1, 2, 3, 4. The top number says, hey, stop. You're done. Add these up together. So we're going to just go ahead and add this up together here. We're going to get 1 plus 4. 1 plus 4 plus 9 plus 16. All right? So we're going to get, what's this? 5 plus 9 is 14. Plus 16. And that's going to be 20. That's going to be 30. Okay? So this sigma here is going to be equal to 30 when we calculate it all out. All right, let's go ahead and do the next one. So at any point here, I've got a practice problem here in the middle, but you can try any of these out on your own, and then pause it and then see what you can get as practice problems. Okay. So this is n equals 1 to 3 of n factorial. Now, if you don't remember what factorial is, remember factorial is when you take and you go 1 times 2 times 3 times. Actually, if we want to work backwards. So if we had like 3 factorial, we go 3 times 2 times 1. We have 5 factorial, we go 5 times 4 times 3 times 2 times 1, and we just keep going, right? So let's take a look at what these look like. So we're going to plug this in. We're going to plug in 1 here. So n equals 1. 1 factorial. Or as I like to say, 1! Okay. Maybe not so scary, though. N equals 2. Okay, plug it in. 2 factorial. Plus n equals 3. We're going to stop here, right? Because it says just go to 3. So let's add all these up together. Remember, 1 factorial is 1 times 1, which is 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. We add that up together, 6, 7, 8, 9. Reminds me of a joke. Okay, so why don't you take a second, pause it, work out the practice problem while I erase the board. Okay, so let's go ahead and work out this practice problem. We're going to plug in 1 in for I. Now it's not, no, don't get confused with I, the imaginary number. This is just a variable telling us, like an index variable, okay? So we're going to go and plug in 1. So we're going to go 2 times 1 plus 3. That's I equals 1. Plus, okay, now we got I equals 2. 2 times 2 plus 3. Plus, we got I equals 3 coming up. 2 times 3 plus 3, right? Because we started at 1, then 2, then 3. Now we got 1 more, which is 4. So we got 2 times 4 plus 3. Oops, why did I keep putting a T there? Jeez, I equals 4. All right, so let's go ahead and add up. I'm just going to do it right above these guys here. 2 times 1 plus 3, 3, 4, 5 is 5. 2 times 2 is 4 plus 3 is 7. 2 times 3 is 6 plus 3 is 9. 2 times 4 is 8 plus 3 is 11. And then we're going to add all this stuff up. So we've got 9 plus 11 is 20, plus 7 plus 5, 27. 27 plus 5 is 32. So I believe I get 32. Let me check that. I want to make sure I'm correct on this one. 9, 10, that's 20. 25, 32, that's right, okay. Boom, okay. Let's take a look at something else that could come up. Let's say we're not given the sigma, but we want to find the sigma. So let's say that we are, I'm sorry, just taking time on my camera here. Let's say we want to get this and put it into sigma notation. So what we're going to do is we first check, the easiest thing to do first is check to see if it's arithmetic. If it's an arithmetic series, then we can just use the formula for arithmetic series, and that gives us our function, our formula. So this one in particular is 3 plus 6 plus 9, right? We add 3, add 3, add 3. So we've got an arithmetic series here. So we know that the formula is a sub n equals a sub 1 plus n minus 1 times d. So we're going to go ahead and use that formula to finish this sucker off. Okay, so d is 3 here. And a sub 1 is 3. So I'm just going to go and plug this in. A sub n is equal to 3 plus n minus 1 times 3. And I'm going to go ahead and simplify this out. Okay? So we're going to get 3 plus 3n minus 3, which gives me 3n. Well, that's nice. So this is my formula. So when I'm going to do my sigma here. So we're going to have, okay, let me erase this real quick. Hopefully you have that written on your paper here. But we found out that a sub n was 3n. So I'm going to do my sigma, and I'm going to say 3n, n equals, okay, let's think about this. I'm going to plug in a number in here, and I should get the first term. All right, so what number do I have to plug in here to get my first term? 1. So I'm going to start at 1 here. And then wait a minute, dot, dot, dot. Well, dot, dot, dot doesn't really end, does it? So, well, if something doesn't end, what do we do? Go to infinity. Okay, so we're going to put infinity up there. This is an infinite series. Okay, so that's how you write that. Why don't you try this other one out and then pause it, and then we'll start. All right, so let's take a look at this one. Now, this one's a little trickier. Okay, this is not arithmetic. If you know a little bit about something about geometric, this is not geometric either. So we got to be a little creative in what's going on here. Now I do notice that 1/2, 4, 9. So, you know, I think I messed this up. I should have had 1. I meant to put 1 there. Sorry, guys. So now that's the problem I really wanted. Sorry about that. But let's take a look at this one. This is really what I wanted to do here. And we notice that 1 is 1 over 1. Right? And this is, notice that these look like squares to me. This looks like 2 squared, and 3 squared, and 4 squared. In fact, 1 is 1 squared. So I have squares on the bottom, and then the top are all 1. So let's go ahead and take this sigma, and we're going to start. Well, let's figure out the formula first. It looks like if I start at 1, I could have 1 squared. And then if I start at 2, I have 2 squared, and then 3 squared, and then 4 squared. So it looks to me like I'm going to have 1 over n squared, and I'm going to start at 1, so I'm going to plug 1 in there. And then it's going to go, well, this one again is dot, 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 so it's going to go out to infinity. Now, what if it stopped? If it stopped, I just got to figure out what's my last term, and then figure out what my number here is going to be. Okay, this number again is not, it's not your last term, it's your nth term, the last one that's going to be there, not the actual number. Okay, some students get that confused in that they think that this n here means it's the last number in our sequence, in our series, but that's not what it means. It's how many terms we're going to go out. 1, 2, 3, 4 terms. Okay. All right. So that's it, guys. Sigma notation.